If you have been building with LLMs, you know the struggle. Managing conversation history on the client side, juggling massive context windows, and trying to orchestrate complex agent workflows. It gets messy fast. But what if the API itself could handle the state for you? Welcome to our deep dive into the new Gemini Interactions API. Based on the latest technical explainers, we are going to break down how the single endpoint changes the game by unifying standard models and powerful autonomous agents. Let's dig into this. So I built this website for you. You can go in and change your key in here, add your own Gemini API key to try out some of the demos in the project. But here it is. So until recently, the API was built around generating content. That's what LLMs were good for. So we had the API which is generate content API. This is a traditional stateless interface where you send the entire conversation history with each request if you don't want the model to forget everything immediately after it responds something. So in this mode, the context is lost quite a lot. I'm going to change the zoom in a little bit. So for example, in this question in here, we have this question, who's Marie Curie? We ask for the model generates a response. So in this case, waiting. The model can generate the response. So the response was generated. But then if I ask a follow-up question in here, what awards did she win? It does not know anything about the previous conversation. So I would have had to pass in the more context in here. So it's like, it's a good example in here, she won, but it doesn't know that previous conversation I had Marie Curie as the example or the question that I asked. So this conversation context is lost, and people have built a lot of things around it to maintain that context. But that changes with Interactions API. So Interactions API comes in here where it shifts this intelligence, this state, keeping the state management and a lot of other things onto the server side. So you start by creating a session and the model remembers everything automatically. So this is stateful intelligence. So in this example, the interaction object is maintained on Google's infrastructure. We only send the new message and the history is preserved. So let's start with doing this again. So same thing, we send who's Marie Curie, and we should get an interaction object in here, ID, that will be our interaction ID. So this interaction ID is the one that we'll send again next time to say this is where we were in our last conversation, and let's continue from this point. This also allows you to say branch out from conversation. So you can always go back to this interaction ID and branch out from here into a different conversation. So we're going to pass this again in our follow-up message. It's happening behind the scene. All the code is on GitHub, so you can take a look as well. But now when I pass the next question in here, it's going to utilize the interaction ID in there, and it's going to give us a new interaction ID because that's where the new branch of the model is. But now it knows exactly what the previous conversation was. So we have a better response in here. So this is just a very basic example of what the stateful intelligence with Interactions API brings. But like, what was this friction? So the stateless brought a lot of friction before Interactions API. The context management was a tax that an application developer had to pay. And then there were a lot of things that came out from to solve these problems. So let's go one by one. So in this example, there's latency. To solve the latency, this is time to first byte increased linearly with the size of history payload. So as you go longer into the conversation, either there were details where we would like do semantic caching, or we would do distillation to keep the models faster, or people would put your conversations into a vector database or some kind of database to keep the context there. And then it would use those databases to pass in only the relevant factor to the next conversation. So this is a lot of bypass around the cost of latency in here, because as the conversations grow, the latency kept increasing. Then we also have complexity. So this, since we had the stateless management on the server side, users or builders had to build a lot of complexity on their end. So this complexity came in forms of orchestration frameworks. So like either you have LangChain or some other middleware like that, or some semantic kernel to perform history truncation. So this happens a lot if you have been using any code editor tools where they quickly fill up their context window and then they have to truncate some of the context. And that ends up losing some of the details in the conversation as well. This also involved external state stores. So you could use Redis or Postgres to manually persist and retrieve session history per user ID. So a lot of people have built their own solutions around this. I know I have built something like this. Then of course you have to have prompt pipelines where there would be like, once you get to a certain size, you would automatically summarize and put it into a running memory. People have different kinds of memories in here. So all of these different things are workaround around this complexity part. And some of these might still be valuable in going into the future, but not in this setup right now. And then we have reliability, where we needed different queues because you wanted to persist the conversation across network failure, server restarts. You need to have checkpoints, you need to have client-side hydration in here, because if you kept the conversation in local storage, you need to make sure that when the page reloaded, you are sending the full context and details like that. So this stateless API has added a lot of friction on this. Now the goal is to improve and reduce this friction, and Interactions API does that. So let's see what does the interaction object look like. So it's the addressable brain state that is serialized on Google's backbone. So it's essentially a glass box. So think of, there's a lot of things that are happening inside that box that you can see, but you can't really change a lot of those things. So for examples in here, we have an input prompt where I send this prompt, and we'll see an example output in here where we have the ID of the conversation that's happening. We passed in Gemini 3 Flash, and we have the signature where this is the model's thought signature, where this is the internal state of what the model was thinking. This is encrypted, so that's why we can't see it. But this would be very interesting if I could get this decrypted. I actually haven't explored the API enough, but it gave the answer in here. But now we can also use this, we can continue this conversation forward as well. So this interaction object is essentially the brain state. So this signature maintains throughout the next conversation. So if the model originally went into the wrong direction, and if it's a complex problem, the model can look back and say that, hey, I incorrectly went into a wrong direction, let me course correct. So this whole prompt, this whole object, you don't have to maintain on your end. This whole interaction object is maintained on, in this case, Google's backbone infrastructure. This allows you to do a lot of interesting things. So right, we have the internal monologue and we have the persistent history. All of this is stored on their side. So now this allows us to do a lot of different things. For example, background execution. So earlier, what used to happen is Interactions API, before Interactions API, you would get responses and you try to break it down to small chunks so that you don't, you figure out exactly what you wanted to call the model for. But now with this, we can just do directly a function call directly in here, and it can take its time. It can, so this example is custom tools that you have defined. You can also use MCP servers in here very easily, so you can provide the type of MCP server and your weather service and the URL, and it automatically takes care of it. I don't think this is the right URL, but I just put it in here. And then you can also use the tools that are available from the tool providers themselves. So in this case, Google provides a Google search tool on their Gemini API. You can just directly use those. And all of these would run multiple searches. So in this example, Google search might end up running multiple different searches. But then you don't have to, as an application developer, maintain all that context on your end of what are the searches that you ran. You might want to, but you don't have to, a lot of these things. This also opens up this new possibility of these model providers start to build agents on their end. So in this example, we have a deep research agent that Google team ended up making it available on API, where you can just use start the searching in here. So it just is doing the deep research for you, and we are seeing the responses that are coming in. It's a first high-level agent that is available via Interactions API. It fully autonomously plans and executes a complex research task. So in this case, it did the research. This is simulated version, but we have sample code in here as well that you can run to generate your own actual what the research agent would look like. So the curl request, and we run it in the background. So this essentially gives us interaction ID, and then we can use that interaction ID later to poll for it and see whenever the results are ready. So this allows you to offload a lot of this task that would be running on your servers to be totally independent and run it on Google servers or whoever the model provider ends up being. This is causing an interesting shift into the conversation, and I feel like the shift, according to me, is system 1 versus system 2 thinking, where the models that are more optimized for live use cases are gonna become more high-speed presence-based models. So this, in this case, native audio streaming. I won't try to initialize this, but you can click in here and try out the live API, where you can talk to the model directly and it will try to give the responses fast. Let's actually try it. Why not? It might ask for permission. Allow this time. Hi there. How are you?
I'm good, thanks. How are you?
Oh, wow. Okay. I did not realize how loud my voice was. My speakers are. Sorry about that for whoever is listening in. Might wake you up. And then, so in this example, on the left-hand side, we have multimodal live capabilities. Anything that does not require a lot of thinking. It's still doing some thinking, but not a lot of thinking. On the right-hand side, these are more of the models that require cognitive reasoning or any kind of deep running task, long running task. They will keep getting moved to this kind of interactions API. I think that's pretty good actually, because these tasks do require some planning, some thinking budget that systems can utilize to give you these deeper, more well-crafted responses versus quick responses that are the quality of system one models at this point. Yeah, so I don't know actually how long it will take, but this is the exactly proper search that it does. So it might take some time. This actually changes the technical economics of the platform, where the ROI is driven a lot by context caching and state management. Now you are relying on an external provider for this context caching and state management. And by holding this memory on the server side, you are bypassing the history tags on your end, which would require you to re-upload the context for every interaction. So think of this history that you would have saved on your end and then would have re-uploaded every time. So I did some simple calculations around here. If you are a customer support after a 2010 conversation where users asking for detailed questions about a product, history grows with every turn. That would have costed you quite a lot in here, versus now the total session cost is way lower. Same, you will see the deeper the questions are, the more savings that you are seeing in here. So in this example, legal analysis for a 2 million token window for 5 specific clause questions, it would have taken a lot more in a stateless manner, because you would have to send the whole document every time. But now with this, we have one session maintained, and a lot of these tokens are cached, so you can just, your new questions don't incur the same cost of sending the complete document again and again. Same for this game use case in here, where a long running narrative, you don't need to maintain that on your end. You just keep using the conversational object that we have. Now we look at data analyst example in here, same, where it would have cost quite a lot. Now we are saving a lot of automations that it allows you to save on. So I feel like the future of this looks very interesting, where of course these are gonna be available on Google's Vertex AI product platform, and where it will have like more enterprise features for HIPAA compliance and SLAs and stuff like that. But this also opens up the platform for Google to build their own agents. We saw that they already built the Deep Research agent, but I'm sure they will add some more agents in here over time. This also makes the chain of thought, or this thinking platform that people were building on their own and everybody had their own implementation of it, it makes it a very much a commodity. This also starting to add some generative UI. I might do another video on agent to UI, A28. I forgot what it's called, but there's a new framework emerging where rather than always asking questions to you in text format, agents can now show you a UI as well. And some of this is right now purely generated, like written one time, but it could in future become generative UI. Of course, this also allows you to do universal memory, because state will not only just persist within an agent, but across the whole mesh, across multiple agents in this example as well, which is also another thing that people had to build a lot of things on their end. And this also makes it away from trying to respond as fast as possible to more proactive partners and anticipating the need of users, because now you have the complete context in the conversation. So I hope the future looks amazing. The whole code is on GitHub. I have linked to Gemini API docs in here as well. Let me know what you think. I'm looking forward to it, and enjoy your holidays. See ya.